All right, so on the second one, this incorporates what we did last week with introducing the unit circle. So let's just review our unit circle for a minute, and you have to know this. You must have all these parts memorized. Oops, that was terrible. Okay. All right, so this is my x-axis, my y-axis. It's the unit circle, so every one of these points, this is 1, 0, 0, 1, -1, 0, and this is 0, -1, okay? So we still have all those points. What makes this a unit circle? Why is that? What does that mean? Anybody remember?
All the points are the equal distance from the center.
Yes. Why is this the unit circle? And D'Angelo gave a beautiful answer. Just gonna put a happy face. All of the points are equidistant. So did you say equidistant from 0?
I said the center.
From the center. But specifically, how are they equidistant? Did you give me a measurement for that? Because that's the definition of a circle, any circle. What makes this the unit circle? Yeah, Christian. So all the points are equidistant from the center, and the radius is 1. That equidistance is 1 unit in all directions, okay? You can have other circles, okay, equidistant from the center, but those points, say this one's 4 units away, okay? That one is not the unit circle. It's a nice circle with radius 4, but it's not the unit circle, okay? All right, so just I just want to keep driving home some of this terminology so you guys it should click in your brains. Unit circle, radius 1, okay? That's got to go together like peanut butter and jelly, okay? All right, so here we go. Now, if I'm measuring the distance in something called radians, which we're going to talk about in more detail later, this stop is pi over 2 units. If I go that distance from 0, 1, 0 to 0, 1, that's pi over 2 units. What's this next one measure benchmark stop?
Pi.
Pi. And the next one?
3 pi over 2.
Over 2.
Beautiful. I love the participation. And the last one?
2 pi.
2 pi.
2 pi. Great. Oops, I don't need that line there. All right, beautiful. Now, the only other thing you need to know that will help you do these more quickly is these decimal approximations of the ones we just read off. So pi over 2 is approximately what decimal?
Is it like 1.4?
1.57.
1.57, okay. Pi, 3.14. 3 pi over 2.
4.71.
Good. And 2 pi?
628.
Yep, 6.28. So this is information, again, you want to just know it, okay? Quick. Pull that out of your brain fast, okay? Now, we're gonna look at each one of these. This is 4 little problems here. 1, 2, 3, and 4, okay? So the first one, let's do 2 and 3 first. Let's look at this sine of 3 and cosine of 3, because those are kind of a 2-for-1 deal. They're very much related. So first we need to walk 3 miles around the circle. So I'm going to start here, and I'll use my use the highlighter, even though it's not as precise, but you guys someone tell me when to stop. Okay, I'm walking. Tell me when I get to 3 miles.
Stop.
That's pretty good. Okay. The highlighter is not the most accurate. Okay, so I'm going to stop just short of 3.14. Everybody good with that? Right? And then we need to estimate these points. So x is approximately what here? It's not really supposed to look like it's more than 1, but it's about what?
0.99.
A beer? I don't like that. You guys don't do that stuff in the chat. All right. So it's going to be negative 0.99, and then y is going to be a little bit up just off of 0. So it's about 0.1. Okay. So I'm looking at this coordinate. Okay.
Wait,
Now-
Professor Ed.
Mm-hmm.
So when we're just given like sine 3, cosine 3, we're just supposed to basically guesstimate.
Yes. Yep,
Okay.
you're guesstimating. I like that. I like that a lot. Okay, so remember that sine is which coordinate and cosine is which coordinate. What is sine?
Y and cos is
Y.
x.
Yes. So once you have that stop, once you estimated your points, your xy, then it's just a matter of putting it together with the sine. So sine of 3 is approximately 0.1, and cosine of 3 is approximately negative 0.99. Okay, that's last week. That's what we were doing last week. Now, tangent of pi, let's look at tangent of pi. Okay, that's an exact stop. All right, I'm going to use this blue here. If I go around, this is pi. Okay, tangent is sine of pi over cosine of pi, which that point there is going to be sine is y coordinate is 0, x coordinate is negative 1, which turns out to just be 0. Any questions about that? All right, last thing is this negative pi over 3. This is not, this isn't necessarily, well, there is a pi over 3 on your unit circle. I don't care about that though. We can just estimate this. This is approximately negative 3.14 divided by 3. Okay, that's just arithmetic. Let me divide this. 3 into 3.14, this goes once. Bring down the 1, that's 0 times. And then bring down the 4. This goes in 12. I have a remainder. But I don't care so much about that. I'm just trying to get an approximate decimal. So this is approximately negative 1.04. I believe that. That might be rounded. You're, again, should be able to do this on a calculator. If you're just using number sense, we could think about it like 3.14 is a little more than 3. So when I divide that by 3, the answer is going to be a little more than 1, right? 1 times 3 is 3. So if I take 3 times something a little bit more, I'm going to get a little bit more than 3. Or you can just divide it. All right, now let's put these in order. What is the smallest number here? I'm comparing 0.1, negative 0.99, 0, and this. What is the
Pi over 3.
smallest? What is it?
Pi over 3,
Yeah,
the negative 1.04.
that is the smallest one, negative 1.04. All right, what's next?
0 or the negative 0.99.
Yep, so it's cosine of 3. Then 0, tangent of pi. And then the largest one is sine of 3. Okay. Questions? So you are going to approximate or find these exact numbers and then put them in order. Let us do a few more of these. I like this other one I picked in my last class. These are a, by the way, these you will find on the final exam.
Upstairs.
Look at the airplane. Go find it.
Ola, you're not on mute, but that was very cute.
Sorry.
At least it was a cute moment, not an embarrassing one. Okay, so here we go. Arrange in order from smallest to largest. So example 2. I want you to do cosine of 5, sine of 5, and then log base 5 of 6, and then tangent of 2 pi. Okay, I'm going to give you guys a couple of minutes to see if you can figure those out. At least get their approximations. And let me assign, when I come back, let's give this. How about, Andrew, I'm coming to you for this one. Mihaly. And then this one, Rodney.
So I have a quick question.
Mhm.
When there's a like a number after log, like log, instead of log 5 of 6, let's say it was like log 3 of 2, what would we do to find those? Because it's like I don't really know.
Well, log base 3 of 2 is going to be a similar process to log base 5 of 6. But it's actually a little bit harder. So how about this? Do the best you can with these. Think through these. And I'm going to go over this in detail. Just give me 1 minute, okay? I want people to have a chance to think about it first.
All right.
But yeah, we'll talk about it for sure. Okay. Andrew, are you ready? You want me to come back to you?
Nope, I'm good.
Okay. All right.
Um,
Walk me through this.
so cosine of 5 would be 5 miles.
Yep. So you want to tell me where to stop?
Yeah. Stop.
Good. Okay. Okay, so this is about 5 miles. Remember, this is 4.71. That's why it's important to just know those numbers, okay? All right, so would you estimate your point to be, Andrew?
I'd say like it wouldn't be like negative 0.99. I'd say like a little bit less than like maybe 0.96, negative 0.96.
Is that for X or Y?
That'd be for Y.
Mhm. Okay, what about X?
And then I would say X is about 0.5.
0.5. Yep, 0.5, 0.4, somewhere in there. Okay, all right, so then go ahead and give me cosine and sine.
Cosine of 5, or I mean sin of 5, wouldn't that be like 0.96, negative 0.96, and then cosine of 5 would be 0.5.
Okay, nicely done. All right, so just to recap all those steps, you had to first walk around your unit circle. Thank you, Andrew. You had to walk around your unit circle to 5 miles, find your X and Y coordinates approximately, and then you assign X goes to cosine of 5 and sine is this the Y coordinate. Sine of 5 is the Y coordinate. Any questions on that from anyone? All right, Mahali, I gave you the hardest one. Are you ready? Are you there? Mr. I don't know if I say Aranis or Aronis. Mihaly? You know what I'm going to do for next semester? Oh, tell me if this is a jerk move, guys, or if you would find it. Is it a jerk move if I download like the Jeopardy theme song? You know, you're like waiting for an answer and then I just play it. Would you be amused or offended?
That'll be funny.
All right. Amusing or offensive? Some people will probably have their
it's
feelings
pretty
hurt.
good.
All right. Okay, so maybe something's going on there. Would someone like to take this, or anybody get an approximation?
I'll do it.
All right.
I got
go
an
ahead, Dan.
approximation of 1.1.
Yeah, that's actually really good. All right, so let's go through this in detail. So log base 5 of 6, that's the exponent that goes on 5 to give you 6. Well, that's kind of a problem, right? Because 5 to the first is 5, and 5 squared is 25. And so it's clear that there's no number in between 1 and 2 that's going to work out perfectly. So we can only approximate. So it's going to be, so you see that 6 is way closer to 5 than it is 25. So that means that my exponent's got to be pretty close to 1. So maybe 5 to the 1.1, like D'Angelo suggested. It's pretty good. So that's just an approximation of 1.1. Any questions on that? Now I want to also, at the end of this problem, since we're right here, actually let's address the one that Abil brought up. Let me show why this one's a little bit tougher. He said log base 3 of 2. Let me just double check. Yeah. So again, that's 3 to some power is going to give me 2. Well, that's a little rough because 3 to the 0 is 1 and 3 to the 1 is 3 and 2 is in the middle. Do you guys see that? So what would you approximate that power to be about?
0.2?
Yeah. Well, it'd be about 0.5 or 1/2. But 3, yeah, the square root of 3 is definitely a decimal. So 0.5 is actually not it, because I mean, it's a good approximation, but square root of 3 is not 2. Like we know that square root of 4 is 2, right? So it's actually going to have to be something a little bit smaller. So like maybe 0.4. So this would be approximately 0.4. So see, that one's a little dicier, I think. Just my personal opinion, but all right, so very good. We have log base 5 of 6. Now let's go on to tangent of 2 pi. Rodney, are you ready? Uh-oh, Jeopardy theme song. It's in my head. Rodney, are you there? All right. How about Nancy? Want to take this one, Nancy? Are you there, Nancy? Oh, okay. She cannot answer right now. How about Joanne? What do you think, Joanne?
I said that it was about like 0 because 2 pi's were like it's 1 0 and then 0 over 1 is 0.
So tell me what tangent of 2 pi is. How do we figure that out?
So it'd be like the sine over cosine. So like the 0 is the y and the 1's the x. So
Good.
0 over 1 is just 0.
Yeah, so remembering from Friday, we talked about this. So tangent is sine over cosine, and then that's y over x. So in this case, it would be 0 over 1, which is just 0. Okay, so now we have all our approximations, and we can put them in order. What's the smallest one? This one, right? Sine of 5. What would come next?
Tangent 2 pi.
Yes, very good. And then cosine of 5, and then log base 5 of 6. Now, do not do this. So students do this. They go, oh, this is 1, 2, 3, 4. Please don't do that. Just take like 2 more seconds. I know you're super busy, but just like 2 more seconds to write it out, smallest to largest, even if it's like with or with commas, okay? So please don't just do that on your papers. Also, the other thing is if you don't show any work, if you just do all of this in your head and it's wrong, there's no partial credit, okay? So again, showing your circle, showing your approximation of that point, and taking your time and showing your steps will be easier for me to give you partial credit, okay? If you make just like one silly mistake. So like, for example, in my last class, I made a mistake. I found the coordinate pair, x and y, and I actually wrote down them correctly, sine and cosine, but then somehow in my final answer, I switched them, okay? So if that had been a student, I would have said, oh, clearly they knew, they understood what they were doing, they just made a silly error, okay? So make sure you show your work. I have one more to show you, but I'm going to save it for tomorrow. I want to start talking about 11.4. Okay, so 11.4 is where we're going to start talking about angles. So measuring angles in calculus. So prior knowledge, you may know. Let's start there. So stuff that you should kind of have an idea of from your high school geometry class. Hopefully I'm not traumatizing anybody, but an angle is composed of things called rays, okay? And they meet at a point, which is a vertex. Okay, so we have a vertex, and these things are called rays, okay? The distance between those two rays is your angle. And we use a lot of symbols like theta. So theta is a common measure for an angle, of an angle. Okay, so that angle is the distance between the two rays. And it does have a special kind of measurement because what we're doing is we're like measuring these incrementally little angles in here. So it's a little different. So let me test you guys. We know this. What type of angle is this called?
A right angle.
A right angle. Okay, so this is 90 degrees would be my theta. Anybody remember like what is an angle that's smaller than 90?
Acute angle.
Yeah, acute angle. It means less than 90. Less than 90 degrees. And then one that is theta is larger than 90, more than 90. What's that called?
Obtuse.
Obtuse. Okay. All right. So hopefully this is like a little bit of familiar territory. Unfortunately, we don't use any of those words pretty much in calculus. I mean, it might come up a little bit. Right angles. We talk about right angles all the time, but acute and obtuse, that's like high school geometry we talk about more. All right. So what we want to do is we're going to look at angles on the unit circle. And these are measured in a new type of measurement called radians. Okay. So the ones I have up here are degrees. So we could say like this is approximately 150 degrees. This one, theta, is approximately, I don't know, 45 degrees. Okay. So you measure angles in degrees, but in calculus, they're really measured in radians. Okay. So let's look at what that means on the unit circle. Yeah, come on. Ugh. All right, good as it gets. All right, so on my circle, or this is on any circle. So so this is any circle, not necessarily my unit circle. I guess angles on a circle can be measured. Let me adjust the sentence. I don't like it. Angles on a circle can be measured in radians. Okay. So let me pick one such angle. So here's my vertex. Here's one ray and then another ray. And so this is my angle theta. Okay. Now, in a circle, you also have a radius. Okay. And this right here, this piece is an arc. Okay. So we often, the symbol for that is S. So S means arc length. R is radius. Okay, and then of course, theta is your angle. All right, so then let's define radian. The radian measure of theta is the arc length divided by the radius, which would be like S divided by R. So that's true in any circle. Now our focus is the unit circle. And again, we'll circle back. You guys like how clever I am? Circle back to my original question at the beginning of this lecture, which is what is special about the unit circle?
Its
Its
radius is
radius is 1.
Beautiful. I am so happy you guys are listening. Makes me feel so good. All right, so so this is a unit circle, radius 1. So look what happens then when I put my angle on. I'm just going to label these 2 points because that means it's clearly at 1, right? Now, if I look at my angle here, okay, here's theta. So theta is my arc length, which I don't know what this is. This is still S, okay, S over, but what's my radius?
1.
Okay. So what this means is basically in so many words that that those distances we've been walking, you know, how I'm like walk 3 miles, walk 5 miles, those are really radians on the unit circle because it's the measure of the radian just gonna be the same as that arc length because we're just dividing by 1. Okay. So the point is that on the unit circle, the radian measure is the same as the arc length, i.e. the number of miles that I've been saying it like that. But really what I meant was walk an arc length, but you guys would have been like, what, huh? All right. Well, maybe not everybody. I would have been. It's weird terminology. You don't tell people to walk an arc length, okay? All right, so let's look at some examples. What the heck do I mean here? Let's do an actual example. So find, let me give you some definitions. Find the approximate or exact measure of theta. So here's one. Okay. Let's say I walk and stop here, and I tell you that this is approximately 1 mile. So then the angle swept out from the bottom, from the x-axis to that point is my theta. What would we say theta is approximately? It's 1 radian. Okay. So that arc length, that distance is the number of radians. Here's a question. How many radians is the entire circle?
.628.
Yes, beautiful. Okay. The whole distance around the circle is 6.28 or 2 pi, right? All right, so here's another one. Yikes, mama. Okay, here we go.
For the first one,
Mm-hmm.
I thought you said theta was s over 1.
Mm-hmm.
So what was s in that?
So I should have been clear. This is on the unit circle, so this is 0, 1, and 1, 0. So s, that is what I'm saying is 1 mile. That arc length is 1.
Okay.
Which is the same as saying that the measure of that angle is 1 radian. Okay.
Yep.
All right. Now, what if my theta is this whole distance? Okay. So my angle here, if you can see it, okay, what angle is this?
3.14.
Or exactly pi. Okay. So this is pi miles when you walk along the circle. So this is pi units. The arc length is pi units, okay? Pi radians. And so also theta is pi radians. The measure of that angle is the same as the arc length. Okay? Now,
So we're not putting degrees then?
what is that?
Are we not putting degrees for the theta?
Yeah, so here's the thing. Like I said, when you get to calculus, we don't talk about degrees as much. We talk more about, like, we put it in terms of radians. So we have to be able to convert. We have to, it's not like, you know, no such angle is measured in degrees anymore, but we have to be able to convert. We have to be able to convert from radians to degrees. Oops, degrees, and vice versa. Okay. And that's really 11.4 is introducing these concepts, but really about being able to convert back and forth. So I like this example because this gives you exactly the conversion unit you need. Okay, so based upon what you see on that last example, this angle is 180 degrees, right? Okay, if it's flat like that, it's 180 degrees, but that's also equal to pi radians. And so this is another thing I want you to burn into your brain, okay? That 180 degrees is the same as pi radians. We're going to use that to convert back and forth. And you know what? I'll show you. I'll start off tomorrow because it is just, we'll do that tomorrow. I looked at the homework. The homework today that's due is 11.2, 11.3, which is from last week. So we're okay. Tomorrow's homework will be on this more, okay? Any questions? Let me put memorize. Okay. All right, everybody. I will see you tomorrow. Have a good day.